I'm going to explain you the product rule with these functions. First, I'm going to explain you with an algebraic function multiplied by a trigonometric function. Then, with an algebraic function multiplied by another algebraic function. And at last, an exponential function multiplied by a trigonometric function. First, we have to know the rule. The rule of the product is the derivative of the function f multiplied by the function of g plus derivative of the function g multiplied by the function of x. We are going to do first f of x is x squared multiplied by cosine of x. We are going to identify first our f and our g. Our f is going to be x squared and our g is going to be cosine of x. We are going to solve the derivatives. The derivative of f is 2x and the derivative of g is minus sine of x. And we are going to follow the rule to solve it. First, the derivative of x multiplied by the normal function of g plus the derivative of g multiplied by the normal function of x. And at last, we are going to have 2x cosine of x minus and plus is going to give us minus sine of x multiplied by x squared. And this is our result of the derivative of this function. Now I am going to show you the product rule using this function. The first step is to identify my f and my g. We are going to have their derivatives. The derivative of the function f is 2x plus 1, and the derivative of the function. Following the rule, we are going to have the derivative of f. First, it is 2x plus 1 by the function of g, 2x plus 4, plus the derivative of function g, that is 2 multiplied by the function of f, 2x squared plus x minus 1. This is my derivative. But this is my derivative. Now I have to present it. I'm going to make this product by this product and this by this. First, it's going to be this by this, x squared. Then this by 4. Then by 1. Then 1 by 4. Plus this by this. This by this. And this one by the last one. Now I am going to get together my similar terms. For example, 4x squared plus 2x squared is 6x squared. Then the ones that have x, 8 plus 2 plus 2 is 12x. Then is plus 4 minus 2 is 2. And this is the presented function of the presented derivative function of my function, my original function. Now we are going to apply the product rule in this function. First, we are going to identify my f, that is this one, and my g, that is this second term. We are going to get the derivatives of both functions. The derivative of f is going to be 1 e elevated to x plus 3. And the derivative of g is going to be minus sine of x. Now, following the rule, we have that first we are going to put the derivative of f, that is x elevated to x plus 3, e elevated to x plus 3, multiply it by my function of g, cosine of x, plus the derivative of g, that is minus sine of x, multiplied by my function of f, that is e elevated to x plus 3. As you can see, we have a common factor here, is this one. So we are going to get the common factor out, and inside of my parentheses I'm going to have cosine of x minus sine of x, and this is the derivative of my function. Now I am going to show you how to make a quotient rule. First we have to know that the quotient rule is the derivative of f by g minus the derivative of g by f all over g squared. First, we have to identify our f and our g. Our f is going to be the one in the top and our g is going to be the one in the bottom. Following the function, we have that we have to put derivative of f. The derivative of f here is 1 and the derivative of g here is 2x. Now we are going to put the derivative of f by the function of g minus derivative of g by f all over x squared plus 1 squared. Now we are going to solve this derivative. This by this is x squared. This by this minus this by this. Now we have to get together the similar terms. X squared minus 2x squared is minus x squared plus 1 over x squared plus 1 squared. This is the result of our first function. Now we are going to get the derivative of this function. First step, identify f and g. This is our f and this is our g. The derivative of our f is secant square of x and the derivative of our g is 1. Following the rule, we have to put derivative of f by g minus derivative of g by f over x squared. This is our derivative. Now we have to present it. It's going to give us like this. The derivative of this function with the quotient rule. First, we are going to identify f and g. We are going to get the derivative of f. But first we have to see that here we have a function inside another function. So we have to make another rule, that is the chain rule. In this one, we are going to identify v and u. My u is going to be cosecant of x, and my v is going to be u squared. The derivative of my v is going to be 2u, and the derivative of my u is going to be minus cosecant of x by cotangent of x. Now we are going to multiply these two. It's going to be 2 multiplied by u minus all these minus cosecant x cotangent x. But now we have to add minus cotangent of x. So we're going to make minus, and the derivative of cotangent of x is minus cosecant square of x. We're going to simplify all this. It's going to give me minus 2 cosecant square of x cotangent of x plus cosecant square of x. This is the derivative of my f. And the derivative of my g is going to be 1. Now we are able to apply the quotient rule. First, I'm going to make the derivative of my f here. That is 2 minus 2 cosecant square of x all of this is going to be multiplied by g. Minus the derivative of g, that is 1, multiplied by f. All of this is going to be over g squared. Now, for presenting our derivative, we have to multiply these terms and these terms. First, I'm going to multiply this term by the x. And it's going to give me minus 2x. Now this term by x. Now goes the number 2. First, I'm going to multiply this term by the number 2, and it's going to give this is a 4. Now we are going to multiply the second terms. This is going to be minus, and minus by minus is plus. Finally, we are going to identify the similar terms that are these two. And we are going to simplify our equation. This is going to be the result of my function. Now I am going to explain you the chain rule. The chain rule is applied when I have a function inside another function. For example, in the first one, that is f of x is 3x plus 5 squared. I'm going to identify my two functions. We are going to name these ones f and u. First, my u is going to be 3x plus 5. And my f is going to be u squared. Now, I'm going to obtain the derivative of these two functions. From the first one is 3. And from the second one is 2u. Now, I'm going to multiply these two. The first one is 2u with this u, 3x plus 5, multiplied by 3. Now to solve it, I'm going to multiply these two. It's going to give me 6 multiplied by 3x plus 5. Finally, I'm going to have 18x and plus 30. This is the result of my first function. Now the derivative of the second function. We have sine of e to the 3x. Now we have three functions. We are going to identify as f, g, and u. The first one, u is going to be this one, 3x. G is going to be e to the u. And f is going to be sine of g. Now we are going to obtain the derivative of each one. The derivative of this one is cosine of g. The derivative of this one is going to be the same, and the derivative of this one is going to be 3. Now we are going to multiply the ones that now are derivated. It's going to be cosine of g, that is e to the u, multiplied by e to the u, that is going to be like this, multiplied by 3. Now, to present my answer, I'm going to have 3 cosine of e to the 3x multiplied by e to the 3x, and this is the result of my second function. Now we are going to obtain the derivative of this function. We are going to identify the function that composed this function. We are going to have f, g, h, and u. My u is going to be 2x plus 1. My h is going to be root of u. My g is going to be cosine of h, and my f is going to be natural logarithm of g. The derivative of each function starting with f, 1 over g. Now with g is minus sine of h. Now it's going to be 1 over 2 root of u. And the u is going to be 2. Now we are going to multiply all the derivatives. First, f over g, that is cosine of h, multiplied by by 2. Now we are going to present our derivative. It's going to be sine 2 over now here we can cancel the 2's and we can make sine over cosine a tangent. So I'm going to have minus tangent of square root of over this one that is down, and this is the result of my function.